Let's try to look at this question. In Fig, a ball is thrown onto a roof, landing 4 seconds later at the height 20 meters above the release level. The ball's path just before landing is angled at 60 degrees with the roof. First, question A, find the horizontal distance d at the travels. And the second question, what are the magnitude and the angle, the CS angle, relative to the horizontal of the ball's initial velocity? So we're going to try to solve this question in time reverse. So that means we are trying to consider the ball is tossed from the roof and landing on the ground level. That's what we want to go consider this time reverse. So we're going to try this question with first A. Question A. So because we want to think this isn't the vertical direction. Therefore, this will find the horizontal distance of travel. But horizontal distance travel distance, we want to see in the how long it would take to getting this level. So y minus y0 equals to v0y, the velocity, initial velocity on the y component multiplied by the time, minus 1/2 gt squared. Okay, some students ask me why we're using this as a negative 1/2 gt squared, because we learned earlier that x minus x0 was v, this is a vt plus 1/2 at squared. But when I solving this question, I instead you will plus 1/2 g at squared magnitude in the acceleration square. I use the acceleration a. I used minus g, minus half g. The reason is because our velocity is always going to negative direction. Therefore, the g is 9.8, positive 9.8, but the direction is negative direction. That's why I use the negative 1/2 gt squared. Okay, so I'm going to plug in the value. So from here, we can time reverse from the toss and throw up from this as a roof, go to the landing on the ground. Therefore, I'm going to consider this negative 20 equals to initial velocity y component times 4 seconds minus 1/2 times 9.8 seconds squared times t is 4 seconds squared. Then we just plug in our distant value. Therefore, I can calculate the v initial velocity y component can be equal to negative 20 plus 78.4 over 4. That is approximately 14. Oh, not approximately. This should be. I can get this number is equal to 14.6 meters per second. So this is an initial, it's not initial, we pretend this is initial velocity that is in the y component. So we want to find out the horizontal distance, then we need to horizontal the velocity, the horizontal x component. Therefore, this will be And tangent, of course, in the v0 x component, initial velocity x component, we can calculate by the initial velocity y component divided by tangent. This is a 60 degree. They give you here is a 60 degree. Therefore, I'm going to tangent 60 degree. I calculate this will be 14.6 meter per second divided by tangent 60 degree. This will be rounded to 8.43 meters per second. That's the first. Okay, so that's the horizontal velocity. But as you know, the horizontal distance is constant velocity. Therefore, the distance I'm going to calculate the final answer. Our velocity horizontal constant velocity is 8.43 meters per second times 4 seconds. Therefore, the answer is 33.72 meter. That's the first question, the A answer. They're asking to find the horizontal distance it traveled. So that is the horizontal distance traveled. Now we want to continue working on second question. Find what are the magnitude and the angle of the ball initial velocity. That means they ask initial velocity. Then for us, because we're time reverse the way of thinking, therefore they call initial velocity. For us, this will be final, the landing point in velocity they're talking about. So we need to calculate magnitude first. Let's try the B. The horizontal velocity or x component velocity will not change, stay as same. So x component velocity, x component same as above. Here we calculate already 8.43. We continue using that 8.43 meters per second. And the y component, if velocity y component is changing, because this is a y component when we toss, that is a entire the travel, entire the process, the gravity continues to work. Therefore, there's acceleration changing, or the acceleration, constant acceleration works on it. So I'm going to write here initial velocity y component minus gt. So initial, we have initial is a y component is a 14.6 meters per second, and minus 9.8 times 4 seconds. Later, the velocity y component become negative 24.6 meters per second. We want to find out the magnitude. Therefore, magnitude of the velocity, we can calculate by square root of 8.43 meters per second square plus negative 24.6 meter per second square. Then we get the value is 26 meter per second. That's the magnitude of the velocity, initial velocity. Then let's continue. They're asking the angle. angle relative to the horizontal of the ball initial velocity. The initial velocity for us is landing here because we time reverse way of the thinking this question. So third question, the question we need to find the angle. So this is the angle we can calculate by arc tangent velocity y component over velocity x component. Therefore, arc tangent negative 24.6 over 8.43. Therefore, we can getting the angle is negative 71.1 degree. That's the question. We finished this will be all three questions they're asking here. Okay, so answer for the B is 26 meter per second. For the angle is 71 degree. Okay, then see you next time.